Hi class, we are on 10B part 3. 10B part 3. So pitch, grade, and slope we're talking about. Consider a road that rises uniformly 2 feet in the vertical direction. So you're going to notice that vertical, the 2 feet's right there. If you're looking at the little arrow, for every 20 feet in the horizontal direction. So as we move 20 feet, every 20 feet we go, the road moves up 2 feet. If that's the case, then we say that that road has a pitch of 2 in 20. And sometimes we reduce it because for every 10 feet, you're moving up 1 foot, and then another 10 feet, another 1 foot. So we say the road has a pitch of 1 in 10 in most cases. It is also common to describe the rise of the road in terms of its slope. And we know that your slope is rise over run, which has a rise of 2 and a run of 20. So 2 over 20 reduces to 1/10. So as a percentage, if we change it to a percentage, it's called a grade. And the grade of the road in this case would be 1 over 10, just 0.1. Moved to a percent is 10%. So 10% grade, I don't know if you guys ever gone on a little road trip and you're heading up a mountain and you see a little sign that says, caution, grade of 6%. So what that means is it's moving 6 in 10 as a percent. So actually 6 in 100 to make it the correct numbers here. 6 feet up, 100 feet across. So for every football field, you're moving a vertical distance of 6 feet up. So that is a grade, and in that case, it would be 6%. But in this case, 1 in 10 is 10%. That's pretty, pretty flat. But what we're going to do is a few problems with that, and in particular things that you might see on your homework. Suppose a road has a 100% grade. What is its slope? What is its pitch? And what angle does it make with the horizon? We don't actually have to do this problem, so I'm just going to cross it out, just because it's something that is not asked on the homework, and I just want to hit the ones on the homework. So the type on the homework are just C, so we're just going to do C. So my video is already long enough. Which is steeper, a roof with a pitch of 2 and 12 or a roof with a pitch of 3 and 15? So if you have a roof with a pitch of 2 and 12, then it's going to be it's rising 2 feet for every 12 feet horizontal movement, or a pitch of 3 and 15 is rising 3 feet for every 15 horizontal feet. All right, now what we're going to do to figure out which one's steeper, it's hard to tell because one's in terms of 12 feet and the other one, or inches, 12 inches, and the next one, the other one is in terms of 15 inches. So in order to compare them, we need to put them in the same form, which I'm gonna put it in decimal form because that'll be a little bit easier. If you take 2 and divide 12, then you would get a slope, so you're moving it to slope, of 0.167. And then 3 divide 15 will give you the decimal slope, 0.2, of the pitch of the second roof. Now, 0.2 is greater than 0.167, so it's a bigger slope or a greater slope. Means it's going to be steeper. So the bigger slope, the steeper it is. So it's going to be the roof with a pitch of 3 and 15. All right, and that will be that. Now, really quickly, if it has an 8% grade, then that means 0.08 per 100, right? So, and then the pitch of 1 and 9, if you want to put that into decimal form. So 8% is a 0.08, and then a pitch of 1 and 9, if I take 1 divide 9, I get 0.11. This one actually is going to be steeper because it's greater. So the pitch of 1 in 9 is going to be the steeper slope. All right. I went backwards and did one I didn't say I was going to do, but that's all right. We have a couple more problems and Pythagorean theorem to hit next. So I'm going to go back to the PowerPoint. And we're going to look at the Pythagorean theorem. Now, the Pythagorean theorem applies only to right triangles, of course, right? It's only triangles that have that right angle right there. The Pythagorean theorem states that, and I always like to go with the hypotenuse first because I like to find the hypotenuse that's going to be the longest side if you're only given measurements, or if you're given the picture of the triangle, then it's going to be the side that's across from the 90-degree angle. That will be the hypotenuse, or the longest side, and the Pythagorean theorem says that your hypotenuse squared is going to be equal to the sum of the squares of the two legs. The legs form the right angle. So c squared is equal to a squared plus b squared. Now, if we're finding area, we're going to combine a few things that we know already. If you're finding the area in acres of this mountain lot, and we have to be careful to note that 1 acre is 43,560 square feet. So in that example, and again, I can't write on this, so I'm going to go back and forth lots of times. It's kind of like a dance. Find the area in acres of the mountain lot. So, oh crap, I can't. What is that, 250? 250 feet? And then 1,200 foot property line. All right, so that's what we have in measurements. I hope that's what it is. If it's not, then that's what we're going to make it for now. We'll do the problem like that. It's just for you to see an example of the homework. So what we need for the area of a triangle, right, is 1/2 base times height. Now, the base and the height are the legs of a right triangle. In this case, it's a right triangle. So this is going to be your height, and this is going to be your length. So if I have 1/2 base times height, length is base actually in this case, so we have 1/2 base times height, of course. Now, we have one of them. We have the base, 250 feet, but we don't have the height. We don't know what that height is. So what we have to do first is we need to find that height. What we have is 1,200 squared is equal to height squared plus 250 squared. And that's your Pythagorean theorem. Your hypotenuse squared is the longest side. It's the side across from the 90-degree angle, and the hypotenuse squared is equal to base squared times height, or plus height squared. So we're going to subtract 250 squared, and I know I'm leaving these in numerical form, which is fine, which gives us height squared is 1,200 squared minus 250 squared. And then to solve for that h squared, we have to take the square root. I like to do it that way because this is what I like to put in my calculator, and I don't like to leave to chance that I might make a mistake here and there. So I'm just going to put in the numbers and let the calculator use its programmed knowledge to come up with order of operations and everything, even though I know I could probably do it. It's just easier to have the calculator do it. So when the calculator does that, it's 1,173.7. Whatever these are, feet, 1,173.7 feet. All right, so that goes there. That's that side. So found that. Now I'm going to find the area. So the area is going to be 1/2 times 250 times that, 1,173.7. All right, and it's area, so it will be square feet. So if I put that in my calculator, I'm just going to do 0.5 times 250, oops, maybe you can see that, times 1173.7. All right, and that is 146,712.5 square feet. Okay. Now, if you're finding the area in acres, this is the area in square feet. So if I have 1 acre is equal to this many square feet, what I need to do is I need to multiply using our unit exchange that we talked about many units ago. And I need to have square feet on the bottom, 43,560 square feet. So my square feet divide out, and then 1 acre on the top. And if I multiply that, then I can come up with acres. My square feet are gone. So what I really need to do is 146,712.5 divided by 43560. 146,712 and a half acres divided by 43,560. And that's what we're going to end up with. So I guess I had to not move that. I already have that in my calculator, so I'm just going to hit divide. 43560, 43,560 square feet. And I get approximately 3.37 acres. All right, and there you go. Now, I have about 5 minutes to hit similar triangles, so we'll try it. I guess I'll break it into one last one, but I think this will do. All right, two triangles are similar if they have the same shape but not necessarily the same size, meaning one's going to be bigger than the other, or scaled up or scaled down version, but the same triangle, same shape and everything, just different in size. So the ratios of the side lengths are all equal, and that's just a condition. What we know about similar triangles is their ratios are going to be equal. So if I take A, this side, A, and divide it by A prime, so A divided by A prime is going to be equal to its corresponding ratio, so B divided by B prime. And B divided by B prime is going to be equal to C divided by C prime. So I have all three sides of the triangles all equal to each other. All right? So if that's the truth, the ratios are equal to each other. I don't know if I just said the sides, I meant the ratios. The ratios of the corresponding sides are all equal. Then we can find missing side lengths. The thing that I like to do is I like to make sure I color code those sides that are equal. So if I have this side and this side, those are corresponding sides. If I have this side, it's going to be corresponding to this side. It's good to figure out what these corresponding sides are. I like to make them different colors, and I know that their ratios are going to be equal. What I do next always is I figure out which sides I have the full ratio of. I know the numbers, I know the ratio, and I have, let's see, B and B prime. I have 9 for B and 6 for B prime. So with those, I have a full set of a ratio. I know it's going to be 9 to 6 for B to B prime. And then with that, I can use it twice. 9 to 6 is the same as 12 to C prime. And I can write that out. And then I also know 9 to 6 is equal to A to 4. A divided by 4. So that sets up B to B prime is equal to C to C prime, and B to B prime is equal to A prime. And then I can cross multiply and solve. So this is 9C prime is equal to 72. So C prime is going to be 8. And then 6A is equal to 36, 9 times 4. So A is equal to 6. All right, and that's how you're going to do the similar sides. All right, I wasn't paying close enough attention to what I was saying, so hopefully, let me just recap. Side ratios are equal in similar triangles. Just make sure that you figure out which sides correspond to which, and then come up with the two sides that have an actual measure for them. 9 to 6, and that gives you your scale factor, your scaling, and 9 to 6 is equal to, make sure you start with the same triangle each time. I started big and went to small. Sometimes I'll even do a 1 and a 2 to remind myself. I went 9 to 6, first triangle to second triangle is equal to A to 4. All right, or 9 to 6, big to small, is equal to 12 to C prime. And that helps a lot when you set them up. If you don't set them up correctly, you don't get the right answer, so make sure that you set them up. It's good to color code. It's good to label the triangles 1 and 2. And you should be good to go. All right, that concludes 10A and 10B. Woohoo! All right, you can do the homework now. Good luck with that. Let me know if you have any questions.